So the next thing I need to do on this Datron here is install a battery. So before I can do calibrations and further testing and check stability and that kind of stuff, if it's unstable, has trouble with drift, that sort of thing, I need to replace opto couplers most likely. I'm tempted to do that anyways, doesn't matter of course because they are old, but I don't know, I might be overkill. But I need to get a battery in there. Now these are actually from jcar.co.nz, also JKU probably doesn't. I've tried ordering them from a few places, tried RS Components first, I don't know, but they wouldn't ship it to me. Element 14 also wouldn't ship it to me, even though I ordered from New Zealand websites. They obviously coming from overseas and I can't ship them for some reason. So then I ordered something from AliExpress, but it's taken weeks and it's still not arrived. And then I found these on Trade Me, which also happens to be Jcars. I should have selected Jcars in the first place. Got some coming from AliExpress, so I'm going to have a few of these laying around, which probably right because they should last for years anyway. But I hope it's not been a waste. These are about $17 each from Jcars, so it's kind of what you expect to pay for these. I think a little bit expensive really, but that's what the typical rate is for these. So anyway, I need to put one of these in here, and then these have got wire leads on them, so I'm going to use the wires I'll attach to them and attach them to the existing points on the board. All we do is make sure I put it in the right around. I'm pretty sure that's the positive in. So let's check the polarity first, just to be absolutely sure, instead of just guessing. Yeah, 3.6 volts as well, or nearly 3.7, so it looks fine as well. Really nice to use black wire and red wire, would have been a bit simpler, but anyway. Yeah, these actually got like rigid wires on them, so that should just pop in. That's actually really loose, that doesn't hold very well. Yeah, I'll do something to secure that, that's not a big deal. So the battery's installed, that's now done. I should specify that don't have the thing plugged in the power at the time you do it, because otherwise you could potentially be shorting the battery out, because you've got earth soldering on, the negative side will be earth, and then that'll be earth, you'll be shorting the battery out, no good. So make sure that, in this case, because I didn't have a battery in there, didn't matter about trying to maintain constants, couldn't have it powered up because it's already gone. If it's powered up, then obviously make sure it's isolated from ground so you don't get a short across the battery effectively. So anyway, that's installed. You can see I put some like this black stuff I've got in here to hold it in place, and that's done. Now I should be able to do calibration on this thing and actually get it to save constants. So I've been playing around with this Datron. I've done some calibration work on it with these. So that's my Fluke 5450A, which I repaired recently, which I also obtained not long ago. And here I've got my Fluke 343A DC voltage calibrator, which I also repaired. And here's my Valhalla 2703 AC voltage calibrator. So I've got AC, DC and ohms substitutions. So I've done some calibration work on this. It all seems to be working. The 1 mega ohm and the 10 mega ohm ranges on here seem a little bit unstable, maybe even on the DC volt side. So there might be something going on with the stability side of these higher ranges. Maybe. I don't know. It seems better when it's been warmed up for a while, so maybe nothing. But I just think maybe at least this range might have something. I need to look into it a bit more detail, but it does seem to be at least be working. I'm happy with that. So I actually got some keys. So these are based off the key which I showed you before in the other video, in the part 2 video. Might be part 3, I can't remember. So I actually got that key recut, well got it cut, and unfortunately the place I took it to used the wrong key, so it didn't fit, it didn't even go into the lock. I can't remember if I showed that in video or not. So I ended up taking it back, getting refunded. And so I've gone somewhere else and got another key, but I could only do it today once we went to level 1. At level 2 they weren't doing key cutting. So the place I went to in the end is where I got the key cut originally when I've got a previous copy made. This key does fit, it does go in. It won't turn because I've got to adjust the actual ridges and stuff on here in order to make it fit on these locks. Hoping I can. I've got 2 keys made because I've got 2 Datron units. Also I got them on this wire mesh because I thought one way, these are a couple of dollars or something for these little wire mesh things, but it's wires. So I could actually maybe use that to hang it onto the back of the unit or something like that. That's the plan. I may not. If I've got this, at least I've got an option of hanging it onto the back of the unit and making sure it doesn't get lost. So yeah, that's the plan there. So what I'm going to do, I think, is clear my desk off here, clear these things away, pull that switch apart again, like I did in the previous video. I'm not going to record the whole thing again, and I'll start trying to modify one of these keys, get it working on these locks. And then get one key to work, then I'll do the same to the other key, and I'll have keys for both my Datrons. I was very tempted to get more copies made. I may still do that. Once I've got a key which actually works on the Datron, I've got a potential then to get copies made and maybe sell them if someone needs one or something like that. You know, I'm tempted. I mean, they're on eBay, but they're expensive. They're like $40 each or something. It's ridiculous. So, don't cost that much to get keys done, really. Plus postage. I may do that just to help some people out if they need keys and they want them for a reasonable price. I mean, it's not really that big a deal. If you've got one of these things You could just actually just stick a toggle switch on the back and wire in parallel with the existing switch and just turn it on and off with the toggle switch. I mean, I was actually really tempted to do it that way myself. There's plenty of space on the back there to stick a toggle switch in. But I wanted to try and keep these original, and might be other people out there too which need to keep the calibration switch intact. Maybe it's something I'll do. Let me know in the comments down below if you think that I should share these keys once I've got them figured out. Anyway, I'm waffling enough. I'm going to pull this apart and work on this key. So here's the key. I've got the barrel back out again, and you can see the two high spots here and here which I need to fix on the key. And the other side, you think maybe if they're a bit low they'll be coming out the other side, and they actually look fine. So I think I've only got to take off those two ridges here, which equate to being these two ridges here. So let's just have a look so I can get both keys side by side. I can show you. So you can see the two high spots and these two bits here. So I've got to file those down and that'll come out a lot better. So here we go, a few minutes later, I don't know, maybe 5 minutes. That's both those keys filed. So basically what I did is I flattened off, so that there is the original ridge, and I had high spot here and high spot here. So what I did is I filed it flat across here first to meet that height there, because that height's original and correct. And I used a round file to file in here and here. And also did a bit of a touch just on this bit here as well. That was slightly high, not much. I just gave that a bit of a touch as well, a couple of strokes with the file. And obviously the same on this key. Exactly the same, both done the same way. This one looks slightly better actually. Not much difference. I think this might be the first one I did, the other one second one. But anyway, as long as these are all flat, then that should work. In fact, I'll go and plug into the other Datron and find out. I'll even leave the camera running so you can hear me swear when I get it wrong. Yep, first key works. Try second key. Yep, that works too. So both those keys are working on that other Datron, so that's great. I'll be surprised if it didn't work. So I've got to put this back together again now. I've got to put the barrel back in. I don't know which way it went. Which way's up? It may not matter, but it's got some thicker bits on here. Anyway, we'll find out, I suppose. Put a key in, so I can slide it in. There we go. So that will just go anywhere in that barrel. I'll do that out of shot, I don't know. Anyway, so I'll go anywhere in that barrel right now. Okay. It's latched in the back, so if I take the key out, that should lock wherever that is right now. Same there too. So that's okay. So what I've got to do now is put the actual switch mechanism back in here and mount all that back on. So if I've mounted this on first, I've got to put this piece back in, which goes in here, something like that. It's got this little angle piece in there. Showed this previously in the other video. And then this will go onto this piece, which I've got to be careful not to pop apart, otherwise it will go everywhere. A bit darker, here you go. So that has to line up, that horizontal piece has to go on that, and this cutout has to go in that bit. So that should go in there somehow or other, if I get it right. If I get the outer part in right first, then I've got to get the inner part in right. Or something. There we go, that's now in. Oh, I've popped it out again. Where's it gone? Trying to get lined up. Is it right? Kind of. But it's, yeah, that's right, there we go. That'll work. Let's put the thing back together. Might as well record myself putting it together, I suppose. So that's all, that assembly there. It's got this, better put it on, this washer which locks it in place. It's got this little flat in it which locks into the threads on the actual key part, or on the barrel. It's got this key part which goes into here, stop it from turning around. So I should better pop that in. Lock that into place. We'll get the front collar, lock that on, well, do it up by hand. Might adjust the nut on the back to get the positioning just right. Now I'll slide the shaft of the switch back on. Got to be careful not to pull it, otherwise I'll pop the whole thing apart. Now I've got these little spacers in here. Nice little spacer here, it's got to go in. Pieces to go through as well. So I'll do the top one first. Afraid you can't really see too well what I'm doing. The reason I'm doing the top one because it's easy to get to, and it means I can try and lock the thing together without it falling apart. Okay, and I can put the bottom one in. Let's go repeat the process. Little spacer, and I'll show you in a second when I get in there. There's the spacer, just there. There's this big washer which holds it all together, and there's the bolt goes through from the back. So, easy enough. It's one of those, one top, one bottom. You can see the bottom one just there. Then I'll just adjust the nuts on the back here to adjust this so it looks good, so there's no step in here. Get that set in the right, and then I'll do the button up on the back of this to tighten it up. So you can see I've now wound this down so it's touching on the front face, and now I'll tighten up the nut on the back there to actually get it all bedded down properly, and then I'll just lock that up, and then that'll be that done. Right, that's that done. Let's get the key, shove it in. Yay, that's pretty cool. So now I've got the actual key profile. I could get more mates. If someone's really stuck and you really want one of these keys, let me know. I might be willing to make a copy for you and send it to you. Just get in touch and I might be willing to do it. Depends how busy I am and how much you offer me to do it. I mean, you can get these on eBay, but they're like $40 just for the key plus postage, and for me to get off from eBay it's like $100, which is horrendous just for a key. I mean, the keys, I don't know, they're not that much to get cut. I don't know, if I'm doing these for the effort I have to go to the shop and get it done as well, my time, that sort of stuff. So if someone really needs one, I'll do it for $20 plus postage. And how's this for a convenient key storage system? Just shoved it down the side of the rail, and there's metal strips. That should tuck out the way, shouldn't get lost then. Shouldn't get broken off either. So I've been playing around burning EPROMs for these Datrons. So this is for the 1062. Now I've got a full set here I've just finished doing for the 1062. These are dated 1987. This is on the EV blog. And I've also burnt the EPROMs for the 1986 version of the 1072. So these are burnt as well. Now I did have problems with a couple of EPROMs not taking code. I'm just formatting them again now. Well, erasing them again in the UV eraser. I think as I'll probably try that set first to see if they work. This should resolve hopefully the IEEE board issue where if it's plugged in it just doesn't boot up. So in theory if I put this whole set in, that should work, and that'd be a slightly newer version firmware as well, be 1 year newer. Whether that's a good or bad thing, I don't know. And also we've got this 1072 set in. After I've done that, I'll check it out, unplug the IEEE board because I don't have the full set for this one, and just put in these ones here onto the digital board and see if it will work as a 7.5 digit instead of a 6.5 digit. That should be interesting. So I'm using a Datronix program here. Although I'm showing you this, I don't recommend it. So I purchased this program a while ago from Datronix, which is in Europe, I think it's Germany. So it's their own brand thing. And the software, although on the PC it's kind of okay, on the Mac it's atrocious. It was a beta version and it's never been updated. And even this software I think it's never been updated. It's 2018 is the last version of this. It's ancient, it's not been supported. These things are still sold. This programmer is about $500 in limit 14. Alright, spend that kind of money on a programmer. I think I spent about $300 on it or something at the time, 6-7 years ago, maybe a bit longer. It's not great support. It's not. I don't get one of these unless you absolutely have to get something which can do EPROMs. Some of these like the TR866s, they can't do EPROMs, so bear that in mind. Now also because I'm doing 2532s, this software doesn't have the 2532 format in it. I mean, it's probably a way of actually making it, but so I built this adapter, which is basically rewiring 3 of the pins, as you can see on the side there, and that converts a 2532 into a 2732 pinout, which means you can program it with a 2732 format, and that works just fine. So we'll see if this actually works. Here's the ICs I'm going to put in. These are the slightly newer version of the firmware. Well, newer year, it might be exactly the same firmware, I've got absolutely no idea. So I'm going to put these chips in here first. I'm just going to do the IEEE first by itself, which is the M3, which is over here. I put that one in by itself, plug it in and power it up and see if it works just like that. If I don't have to do all of them, that'd be quite good, but I might do them all anyway in case there is a firmware difference, but yeah. Right, so I found my IC pullers. I had some sitting around somewhere in here. Anyway, I don't tend to use these on bigger chips because it tends to be a bit violent getting them out. I'd actually prefer to use my tweezers, these ones here. I prefer to use these, stick them underneath there and lever it out gently at each end and wiggle it out. That's much more gentle, which doesn't put in as much stress on the ball and that sort of stuff as well. It's just nicer. Whereas this, when you're pulling on an IC, you're actually stretching the whole circuit board. So, I mean, I actually, with the tweezers, I'm levering between the socket and the IC, right? So there's no little stress on the board. Whereas this, you're yanking directly on the circuit board. So it's a little bit different. I don't like this as much. I know it's like the proper tool, but I don't like it as much. So anyway, let's see if we can grab this one out. This one's already been out a couple of times, so it should be a bit easier. There we go. Alright, so that's that one. And I might reread this one actually, just check it. I'm pretty sure that was blank or something. I can't remember exactly what it was now. There was some weird issue. Alright, here's the next chip. Go in, put it in the correct way around. And there we go, that's it. Right, let's power the thing up and see if it actually works. In fact, before I power it up, I've got to turn it over and plug the cable in, otherwise it won't know. Alright, so let's plug this in. Be interesting to see if it's exactly the same firmware that's already in here. I really don't know. We'll find out, I suppose. Right, there's that in there. Let's get some power sorted out. Power's plugged in. Let's turn it on. 230 watts, that should be fine. Let's turn the main switch on and we'll see what happens to the display. Do we get a boot? No, we don't. So, not that firmware. Okay, so let's change these chips. Which one's which? I've forgotten which one's which. I think that's 18. I can't remember which ones these are. I better go and look that up, otherwise I might put them on places. Right, so 3 chips installed. That's 18, 30 and 35. So we'll try again. What do we get now? Nope, still not good. So let's unplug the GPIB. No more boot. Okay, so that's the later year firmware. We'll boot it normally just without GPIB. So one more test I think I'll do is I'll remove that chip again, put the original one back in again and see if that does anything different. You never know, maybe there's a reason for this problem. Put that one out, get the original M3, which is this one here, put that back in. We'll try again. It could be as a fault on the GPIB board, it's possible. No, don't like that. Okay. What about changing some of the GPIB switches? All off. If I turn them all on, does that change anything? No. So yeah, GPIB is obviously no good. Right, moving on. So the next experiment I wanted to do was to put in the EPROMs from the 1072. So these are the 7.5 digit version. Right, obviously this is a 1062. So we'll put these in and see if it works. Right, so here's the 3.5, goes in there. There's the 3.0. Here's the 18. Right, let's see what this one does. Hey, it boots. That's a good start. Question is, does it work? Right, so I've hooked up the PD VS2 Mini. Let's chuck a voltage out and see if it's actually doing anything. Okay, yes it is registering a voltage. It was. The calibrations are probably completely screwed though. No, it's not working. Just do 10 volt range. 2 volts. 2, 4, 5, 6 digits showing up. If I do filter, there we go. So it's not updating. 2, 4, 6 and a half digits showing up. For the 1 volt range, don't think it's behaving quite right. So the calibration is going to be gone on that much, but the hold's not on or anything like that, so it should be doing its thing. I don't think it's calibration. I think it's a fundamental difference between the firmwares, because this should be showing 1 volt there and it's not. 10 volts is showing that. 100 volts is showing that. Yeah, this is fundamentally different, which is a shame, because it would have been nice to use the other firmware on here. But it's not even updating properly. I'll turn the filter off, I should speed it up. But yeah, I don't think I've actually gained anything from doing that. If anything, I think it's made it a bit wacky. I was kind of hoping it would work. No, well, I guess that answers that question. You can't put the 7.5 digit firmware in a 6.5 digit because it doesn't quite behave right. Which is a real shame. Turn the holding off. Does that make it re-trigger? No? Nah. Nah, it's not right. Okay. We'll put that back out and put the original back in again. Well, the updated 2000 and... Sorry, 2000. The 1987 firmware instead of 1986 firmware. We'll put that one back in. Alright, so 1987 firmware back in again. We've got 1 volt coming out, 1 volt showing up on display. Alright, so let's go to the 1 volt range. There we go. That's doing exactly what it's supposed to do. You can see calibration's pretty damn good. Input filter should go to 6.5 digits. Will that only show? Will it show 6, 2, 4? Yeah, it's showing 6.5 digits on there in that range. So that is exactly right. It's a shame. I wanted to get the 7.5 digit working, but oh well. It was a long shot. So anyway, I've had to play with the firmware. I've now got the latest stuff in there. I'm guessing it's the latest firmware. It's the latest available firmware anyway. Whether there's hardware differences between those years, I don't know. There could be. I know there's constant revisions being made on diagrams. So there's lots of comments about the revisions. Anyway, it seems to be basically working now. As you can see, at least it's measuring 1 volt accurately. If I do auto ranging, I'll take this up. Yeah, 3 volts there. Got 10 volts on here. Because it's got the input filtering, it means it takes a little while to settle. It's got like an averaging thing in there. So there you go, exactly 10 volts. That's working alright now. So doing a self-test with this firmware is giving me error 6. I need to go and check to see what that was. I don't remember. Maybe it's because I've got some stuff hooked up. Let's try and plug in some stuff. I did check it, flick this onto 4 wire as well, because I remember this was something about 4 wire, but I think that's for error 5. Let's do this again. The other test passed, so error 6 is the only one that comes up. Yep, okay, I'm going to look into that one. Maybe a calibration thing. It may be there's a slight difference in this firmware, which means it can't be used on this one. Alright, so error 6 is a resistance range error. So it reckons it's like a 10k test and it's failed resistance. So either there's an issue with the resistance range. I don't actually remember if there was one or not. I should probably put the original EPROMs back in again and retest that. But I thought I'd cleared all the errors on this thing. I thought I had. Anyway, and what's the next thing? AC passed as well, so that's fine. And then we're working again. So, but I do have resistance range working. So I'm a bit confused by that. I'll turn off the input filter. Well, I thought it'd just do what it needs to do anyway. Let's change to a different range and, well, a different function. And let's do the test again without the input filter turned on. Maybe that's causing some problem. I would have thought it would have controlled itself as it needed to in order to do the self-test. I just want to rule that out. Still error 6, okay. Yeah. Alright, so I might pull the EPROMs out, put my original ones back in again, do that same test again, and see what comes out of it. It could be a calibration thing, but as far as I know it's okay. Alright, that's the original EPROMs back in. Let's see what this does for it. If it's still there, then I can relax a little bit about those other ones. Still there, okay, right. So yes, I've got an issue with this still in the ohms range. That's fine, at least I know what I'm dealing with. Okay, I thought I'd fix all the problems, but apparently not. So reading the manual about self-test failure, what it does, it measures a 10 kilo ohm range and it links a resistor across the I positive and I negative terminals, and it measures that resistor voltage with the DC side in order to verify it's working. It measures that voltage, it should be about 1 volt, and then it compares that using the ODity converter against the stored value for that particular test, and it's got to be within 6%. If it's outside 6%, then it will give a self-test failure. So I think I need to check that 10k range and just see what's going on there, or maybe there's an issue with that particular resistor or something. So it's also possible that part of that problem is that the unit's not warmed up or anything like that. It's still basically cold. So what I might do is power it up for a little while, put the covers on, and give it 10 minutes, give it a chance to settle, and then redo that test and see if it still fails. If it does, I might have to relook at those calibration values. I actually just thinking, I don't think I've done the ohms board calibration on this thing. So I've done the analog board calibration, I've done the AC board calibration. I don't think I've done the ohms board calibration. That might be why it's failing, because I haven't actually done that one yet. I might have forgotten it. Well, I've had it on for about 10 minutes now, I've done a self-test and it's still failing, so it's not a warm-up thing. I need to look into this in a bit more detail. So one of the chips that controls this ranging and everything on here is a MC14016 BCP. Now I just got some of those turned up. So what I actually might do is pull that chip out, replace it and see if it changes anything. There's no harm trying, is there? Alright, new chip is installed. Let's see what happens. Will it change anything? I doubt it, but hey, it might be an easy fix. That's like the first easy thing to do, without any real thought or troubleshooting, diagnostic sort of stuff. It was still there, so yeah, okay, didn't fix anything, that's fine. Moving on. So it could even be the relay, because the electrical connections do go through this relay here, and it could be that this needs a clean. It's a little bit of a pain to get out, not too bad, but just slightly. But yeah, I think I might have to even pull this relay apart and give the contacts a bit of a clean, put some cleaner in there, and see if that resolves it too. But of course I haven't actually done a resistance measurement. So what I actually do first is get my calibrator out and stick a known 10 ohm reference in there and see if it measures 10 ohms. Oh sorry, 10 kilo ohms. I've got my calibrator sitting over here on the side, just chucked on the bench, outputting 10k, and I'm getting 10k on the meter. So let's do 10k on here, get the resolution we want. So it should be within 6%. Well, that's within 6%, so I don't know why it's giving an error, because that is reading correctly. That's a bit of a mystery, because it's definitely working. It's a bit weird, really. Let's turn the filter on, get next digit. Yeah, that's okay. It's out by 20 counts or something, but considering the covers are off and it's not warmed up properly and that sort of stuff, it's not that surprising. And the temperature's a bit low as well, it's at 21 degrees. Should be slightly warmer than that, but not much. It seems to be working. So why is it giving a self-test error? That's the weird bit, because it starts on that range measuring a 10k resistor. That's going to require some more investigation, I think. So just out of interest, thought I'd check the 19k, and yeah, that's pretty much there. So again, it's a little bit out on counts. It seems to be kind of right. Maybe there's a calibration problem, and it's got 2 adjustments on this board, and I'm pretty sure I haven't done this one yet. I know I've definitely done this one. I don't think I've done this one yet, so I'm gonna possibly go and look at that. Maybe it needs adjustment on the board or something. So I think I might as well do this calibration. There's only 2 adjustments, so I might as well get in here and do it. It looks like it's fairly straightforward. So I've got the physical manual here. So I need to hook up with the TP1, which is over here, and TP4, which is over here. So that is there and here on the board. So I'll do that. I'll do this calibration whilst I'm in here and get that bit done. Because it happens to be that I need a 10 mega ohm resistor. Well, I've got one. It's right here. Push that button there and turn that off. That's a 10 mega ohm resistor. So yeah, that'll do. Alright, so I'm hooked up, ready to go. Now what I've done, instead of using the calibrator, because of the wire leads, it's introducing a little bit of noise. And the measurement I'm doing is really precise, so I'm just straight on. Got a 10 ohm resistor, 10 mega ohm resistor across here. Because a parallel capacitor, which is there to help reduce noise. And in theory, this should give me the function I need. However, I'm getting a much higher voltage than I thought I should see. I'm getting 2 volts on there now. Should be getting millivolts. Oh, because that's not plugged in. This has to be hooked up to here. There we go. Right. Has to be looped between here and here. You've got a loop between, I've got one of those metal bars between the ohms guard and the I negative. And you have to link these 2 terminals together. But because they're not standard spacing, you can't just use one of these little metal links. You have to use a jumper, which is a bit of a pain. Wish they were standard spacing apart. It'd be a bit easier. I've already done a bit of a tweak on this. I'm getting pretty close. It has to be 0 plus or minus 300 microvolts on the bias. This is a DC bias, and it was adjusted about here when I got it, I think. Yeah, about there, which is 2.4 millivolts, which is way off. So if I bring it back down to about where it should be, I should be able to get it that close, and I should be able to get it basically 0. It's only drifting very slightly with noise. I'll show you in a second once I get it set. It's a bit touchy. It's a shame it's not a 20 turn pot or something on here instead. Those little blue multi-turn pots, or 25 turn or something. Got a little spot here where it's jumping off. I mean, I'm being really fussy here. I'm aiming for perfection, because that's what I tend to do. Right, I think that's about as close as I'm going to get it really. I'll show you. So that's the reading I'm getting. Right, so it should be plus or minus 300 microvolts. So I think I'm within that range. It's got a little bit of drift in there, but you know, noisy environment, that kind of thing. But that's looking pretty good. Happy with that. So the next thing it says to do is to remove the resistor and stick a shorting link across, and then do a basically 0 calibration, I'm guessing. Well, it says resistor, but it means resistor and capacitor. So I'm going to have a shorting bar here. Let's pop that on. I imagine I've still got a link across here. Didn't specify actually. Didn't say to take it off. Right, so what I've got to do now is move my test lead onto TP14, which I need to find. TP14 is just down the side here. It's a bit hard to actually see. It's not like a proper post like these ones. It's like a little link on the board, which this cable here is actually attached to. Just over here. It's a bit awkward. Anyway, I've got it on there. So now we can do this calibration. So what I'll do before I actually do that calibration is I'll link these leads together in place, because it's such a fine value, and make sure I've got it zeroed properly, because it's supposed to be within 2 microvolts, and as you can see I'm sitting at 6 here. So let's offset that there like that. There we go. Hopefully moving the lead by a couple of inches doesn't matter. Right, so there we go, we're getting 74 microvolts there. So this is also, this adjustment is way off from where I think it should be. There's like a mark on the pot through already, which something else has put on it. Oh, popped off. Those adjustments are not set to those marks. So I think that someone's been twiddling. So if I turn it around to where the mark is, we haven't looked at the meter yet. Here we go. Oh, look at that. That's right where the mark is. So, okay. yes, someone's been messing with this. That probably wouldn't be helping the calibration. So 0 plus or minus 2, so I'm probably get a bit closer. So before it was positive value, so let's bring it down very slightly more, well, up slightly more. Okay, you want 0 plus or minus 2 microvolts. Oh, popped around a bit. I can get exactly 0, that'd be good. Then I'll recheck with the nulling as well on the meters. Right, there you go. That's pretty much 0 there, isn't it? So let's just move the probe off again, short them out. So that's shorted. Yep, that's good. So I'm pretty confident there that's well within 2 microvolts. As per the manual. Put it back on. Yep. Looking good. So I'm happy with that. That's the 2 adjustments done, and I'll show you those pots. I'll show you what I'm talking about. So here's the 2 adjustments. As you can see, I've written on R26 and R27. And you can see a little black line that's there. That's from somebody else. There you go. Get the lighting off it. You see it's almost on that black line on that one. And on R27, same deal. It's basically bang on that black line. So this one was actually turned around more horizontally. It's going that direction. And this one here is more vertical. It's going this direction more. So, you know, I don't know, 10 degrees around this one, about 30 degrees around this one, something like that. So that made putting it back to where those marks are has actually got it back to calibration. So whoever twiddled these didn't know what they're doing. That's unsurprising, but yeah, anyway. And apparently I'll go between those 2 steps repeatedly to make sure I've got it completely correct. So obviously one adjustment has an effect on the other adjustment. So I'll go back, recheck the other one, make sure it's still okay. But it probably is, I expect. So I've hooked up onto the other test points. Again, just rechecking that value, and we're at like negative 70 microvolts, so it's still within spec by quite a bit. So that's fine. I'll have to do more work on that part. There are some more steps. I'll check those. So the next thing I have to do is hook up onto TP13 over here and link TP1 and TP3 together. And then it didn't say anything about changing this. Also I mentioned about linking the low to the ohms guard, which I've done with a jumper link. And it says it has to be plus or minus, well 0 plus or minus 50 microvolts. And that's fine, we're getting about minus 30 microvolts. So that's okay, it's within spec. So there's a reading we're getting at that test point. So this is actually for the factory selected value of the resistor. Alright, so if this is off, you have to change resistors on the board to match the factory selected requirements. If it's less than 50, you have to do one particular type, and you have to go above. Anyway, I don't have to go there, thankfully. But yeah, it's good. At least I know that board is definitely okay now. And I probably need to redo the calibration of the ohms board, but that's not a big deal. I've got the calibrator. But yeah, it still doesn't explain why I was getting an error though. I don't think I should be getting an error message for that, but I'll try. I'll take everything off now, put the cover back on, give it a few minutes to warm up again, settle down, and we'll do a retest. So yeah, doing those adjustments does seem to have made a difference. So I'm now getting a slightly different value here compared to what I was getting before. So yes, I will need to recalibrate the ohms board, but that's not a big deal. Alright, so that's everything disconnected. Just self-test it. Does it fail again? Hopefully not. Hopefully we've resolved it now, but it's a little bit odd. Hey, passed. Yes, excellent. That solved it. Good stuff. That's pretty easy.